Number 13 from homework 4 is kind of a strange example because it's asking us not for the definite integral from 0 to pi of cosine of x, but rather of absolute value of cosine of x. And I think going through this problem it'll be helpful to take a look at the graphs of cosine versus absolute value of cosine to really get a feel for what the problem's asking for. So if we graph cosine of x first, maybe we'll graph this in red using dotted lines. From 0 to pi, we know that at 0 we get 1, at pi over 2 we get 0, and at pi we get negative 1. And the graph of cosine looks something like this. Hopefully you're doing a much better job than that. And now what happens when we take the absolute value of that? So when we take the absolute value of any function, we're taking all the positive stuff and keeping it positive, and all the negative stuff and making it positive, right? So I'm just going to graph right over the red line here. From 0 to pi over 2, absolute value of cosine and cosine look the same. But from pi over 2 to pi, we're going to get the mirror image over the x-axis, so we get something like that. Okay, so now you have a graph which is entirely on or above the x-axis, so it's all positive. And when we're evaluating the net signed area by taking the definite integral, we're getting all positive area. Okay, now a way to explain what's going on without the graph, just algebraically, is to consider the function absolute value of cosine as a piecewise function. So to do that, we're going to split it up into pieces which are positive and pieces that are negative, and then change the sign of all the pieces that are negative. Okay, so again, if we're just restricting ourselves to the domain from 0 to pi, we said that cosine of x is the same thing as absolute value of cosine of x when x is between 0 and pi over 2. And then from pi over 2 to pi, it flips over the x-axis. So how do you flip something over the x-axis? You just add a minus sign in front. You multiply it by negative 1. So from pi over 2 to pi, the absolute value of cosine of x is really negative cosine of x. Okay, so now we have a good picture, we have a good sort of algebraic way of expressing what's going on, and we can then figure out how to rewrite our integral without an absolute value of sine, but so that it's equivalent. If you recall, one of the basic properties of definite integral says that we can split a definite integral at any point between the lower and upper bounds. So if I'm going from 0 to pi, I can split it at pi over 2 where this change in sign happens. So I can write it as the integral from 0 to pi over 2 of absolute value of cosine of x plus the integral from pi over 2 to pi of absolute value of cosine of x. Okay, and since going from 0 to pi over 2 and then pi over 2 to pi still gives me the entire interval from 0 to pi, we're okay so far. Now that we have the integral split into the piece where cosine of x is positive and cosine of x is negative, we can rewrite the absolute value of cosine of x in both of these integrals according to our piecewise definition. So we said from 0 to pi over 2, the absolute value of cosine is the same thing as cosine of x because cosine's already positive. So we can just rewrite this as integral of cosine of x. Now from pi over 2 to pi, we said since cosine is underneath the x-axis, since it's negative, that what the absolute value function does is puts another minus sign in front. So you get a double negative, making it positive. So you get negative cosine of x from pi over 2 to pi. And now these two definite integrals added together are the same as the sum of these two integrals, which is, as we said before, the same as the integral that we started with. Now each of these definite integrals should be pretty easy to solve. We'll just do one more little bit of simplifying, which is to bring the minus sign out in the second integral. So I get cosine x dx from 0 to pi over 2 minus the integral of cosine of x dx from pi over 2 to pi. Now one really important thing to notice is that this sum, or difference rather, of two integrals is exactly what you would do to find the total area, or the actual area, rather than net signed area, for cosine of x from 0 to pi. Okay, now, moving on. For the first integral, we're going to take the antiderivative of cosine of x, which is sine, and we're going to evaluate that from 0 to pi over 2. Then we're going to subtract from that the integral from pi over 2 to pi. Obviously we get the same antiderivative, sine of x, from pi over 2 to pi. And then it's just a matter of plugging in and simplifying. So for our first set of brackets, we're going to get sine of pi over 2 minus sine of 0. Second set of brackets, we're going to get sine of pi minus sine of pi over 2. So what does that give us? Sine of pi over 2 is 1. Sine of 0 is 0. So we have 1 minus 0. Sine of pi is 0. Sine of pi over 2 is 1. So we get 1 minus negative 1, which is 2. To quickly reiterate the point that I made a moment ago, evaluating the definite integral from 0 to pi of absolute value of cosine of x is the same as finding the total area as opposed to the net signed area between y equals cosine of x and the x-axis from 0 to pi.